we're going to do solving exponential, so the other equations that we have in this unit. So again, here's the algorithm for solving. It should make sense to you because, you know, Algebra 101 says in order to solve, you undo things. Whatever you do one side, you do the other kind of thing. So if we start as an exponent, what do you think we're going to do to undo it? Apply the log function, yes. Okay, so solving for an equation where the bases are not common. Notice I say the bases are not common. This is a calculator part of the test, the exam. So if the bases are the same, or you can rewrite them as the same, it will be on the non-calculator part. So that's key here. If you can rewrite bases the same, it is faster to do it without a calculator and rewrite in common bases. So anyways, take the log, and we're going to use the common log. What was the common log again? Base 10, yep. Of both sides. And you are going to expand using the log theorems that we've learned. We're going to use algebra to isolate the variable and solve. And how we're going to do this, we're going to put all the x's to one side. And anytime you get stuck, it's probably because you need to factor in order to do this. And then, of course, evaluate using your calculator. So the last step would be using your calculator, because there's no way that you'll be able to solve this without. Okay, so 5 to the power x equals 40. So when it's written like this and we have only one exponent, you can do this two ways. You can do it the old way, which is before you even knew any of this. How would you solve this right now? Yeah, you change it into logarithm form. So I'm going to call this method 1. This method only works if you have one exponent. So method 1. And that I would say change to log form is the method. So x equals log of 40 base 5, and then you just punch it into your calculator. Does everybody see what I did there? Okay, let's punch it into our calculator and see what we get. Remember, this is correct to 3 decimal places. So do 4. Does everybody know how to punch that in? So it's roughly 2.2920. So did everybody get that? Okay, the other way is using this algorithm, and that's how you're going to use the majority of the solving is method 2, because it works for the, you see for b coming up, you have exponents on both sides, so you cannot use method 1. You can't change it to a log form when you have 2 exponents, right? So method 2 is what I've laid out in the steps here. We log both sides. So log of 5 to the power x equals log of 40. Does everybody see what I did? I logged both sides. Yes? So it says to expand using the log theorems. The only thing we can expand is by putting the x in front of that log, right? Hopefully everybody knows that theorem. So x log 5 equals log 40. And then last step, solving for x, right? So x is, divide this out of there, log 40 divided by log 5, which is exactly what I punched in my calculator to get this 2.2920. Okay, so yeah, this would be a 4-mark question. So we cannot change this into log form, but we can log both sides. That's Algebra 101. Whatever I do to one side, I do the other. So log 4 to the power x equals log of 3 to the power 2x minus 1. So somebody asked, do I have to show this step? No, but be very careful that if you skip steps and you make a wrong step, you're actually getting marks for applying the log theorem. So in the next step, this is where you're getting your first mark. So the exponents go in front, right? So x log 4 equals, If you write it as 2x minus 1 log 3, you would lose an error code. Does everybody? You need to have brackets because it's the whole thing multiplied by log 3. Okay? So now this is 2x minus 1 times essentially this whole log 3, right? So I'm going to multiply that in because I need to get the x's on one side. Okay? So x log 4 equals, what's 2x times log 3? 2x log 3. What's minus 1 times log 3? Minus log 3. Does everybody see what I do there? Yes? Okay, so now I need to get the x's on one side. So I need to move this one over. If you want more positives, I would probably move this over and that over, right? I don't like working with a lot of negatives, so that's what I'm going to do. So I'm going to have log 3 equals 2x log 3 minus x log 4. Everybody see what I did? I have one negative instead of two negatives this way, right? Okay, so now I have x's to one side. Does everybody see you may need to factor? This is the case where you have to factor because there's no way you can get it in x equals form at this point, right? You can't combine them together at all. So I need to factor out this x and this x out of the two. So next step, log 3 equals x bracket 2 log 3 minus log 4. Are we good? Okay, what's our last step? We got to get what x equals, right? So what does x equal? Log 3 divided by 2 log 3 minus log 4. And now we're going to punch it all in our calculator. And this is where the mistakes happen because people don't know how to punch it in their calculator. So watch. You need to have brackets when you have a long thing that you're doing. Also, on your graphing calculator, I don't know about some of you, if anybody has a different calculator, but on your graphing calculator, the logs impose a bracket. So if I use my red ink here, the calculator automatically puts a bracket there. Do you see that? So you need to close it, otherwise it's going to think it's log of everything. So because it's just one thing I'm dividing, I don't need brackets on top. You could get in the habit of doing that, but because there's two things here, I need to put brackets here. But watch, you need a bracket there and a bracket there as well. So this is where people make mistakes with their brackets, right? Okay, so let's punch it in. Okay, and so I get 1.3547. Did everybody get that? So let's do the next one. Does everybody see?
Yeah.
What? What do you see? Huh?
The reason why you moved the log 3 over.
So what would we do for C here? Yeah, so if you can, I'm going to do it both ways, but I'm just going to show you. You can rewrite this as the same base. So this is 2 to the power 3x minus 1 equals 2 to the power 2 to the power x. So that means 3x minus 1 equals 2x, negative 1 equals negative x, so x equals 1. Bam, done. Quick, no calculator needed. If you forgot that, you automatically log both sides, which you can. You'll get the right answer. However, if you're on the non-calculator part of the test, you can't do this method, right? So log calculator, I'll just say. So log to the power, log of 2 to the power 3x minus 1 equals log 4 to the power x. Put the exponents in front. 3x minus 1 log 2 equals x log 4. We need to multiply it out. Do you see this is way going to be longer? 3x log 2 minus log 2 equals x log 4. Well, yeah, this test will be calculator, no calculator. So the first couple of questions will be with the calculator and you put it on the ground. So you should know if you get a question like this and it's in the non-calculator part, you should be changing it to the same base. So I'm going to move these two around. So 3x log 2 minus x log 4 equals log 2. Again, factor out the x. Do you see this is way longer than what I just did? Yes? Log of 2 divided by 3 log 2 minus log 4. And we get 1 out of all that. Yes? Okay, so lately they've been asking more complicated exponential solving ones like this, and it's not like they're more complicated at all. First off, people think, and I see this time and time again, and hopefully it's not from this class because I'm saying this right now, people think they can do in the first step 6 to the power x equals 5 to the power x minus 1. And they are wrong, entirely wrong in the first step. You're done, 4 marks. Don't do that. It's called bed math. You got to do exponents before multiplication, right? So, what do? They both have exponents, so we have to undo the exponents by logging both sides. So log of 2 times 3 to the power x equals log of 5 to the power x minus 1. Notice I have brackets this time because there's 2 things that the log is going to. Now we're going to use our log theorems to expand. So what does log of 2 times 3 to the power x become? Log 2. What? Stop it. What does multiplication get expanded to become? You're making stuff up if you're timing stuff now. Huh?
Oh, yeah.
Plus log 3 to the power x equals, if you want, you can put this in the next step. Okay, again, this is just like cosine. If I had cosine of 3x minus 1, was there a formula for it? Yes, all the people that said, oh, I can just do a distributive property and multiply, that is absolutely wrong. Why would I show you a formula, a cos of alpha minus beta formula, if you could do that? So, same thing goes with logs. If you have log of 2 times 3 to the power x, why would I spend a whole day showing you log theorems to expand it if all you had to do is multiply those two together? Do you understand? And those log theorems are on your formula sheet, right? Yes? Those log formulas are on your formula sheet. Okay, yes they are. So this has to go in front. So log 2 plus x log 3 equals, now do you see this is x minus 1 times this whole thing, right? It's totally different. It's not log of something. The log of something is getting actually multiplied by that. So x log 5 minus log 5. Everybody good with what I did? Okay. So, and the question is could I go directly to this step? Yes, you've shown that you understand log theorems. If you're that good, you could go to that step. But you got to show the step where you actually have the log theorems expanded. Okay, what's the next step after I've expanded all of these? Yeah, I need all the x's on one side. I think I'm going to move this over and that over. So log 2 plus log 5 equals x log 5 minus x log 3. Yes? Now what? Factor out the x. It's the same thing over and over again. X bracket log 5 minus log 3 equals log 2 plus log 5. Some people don't show that step and they go direct to the divide, and that's absolutely fine. X equals log of 2 plus log of 5 all divided by log of 5 minus log of 3. So now the hardest part is punching this into your calculator because there's a tremendous amount of brackets. So let's punch it in. .5075. Everybody get that? Okay, we're going to log both sides. So I'm going to actually skip a step and go directly to this. Oh shoot. Is that okay? X minus 5 log 19 equals x plus 2 log 3. Did anybody actually go directly to that step? Or no? You can. I can do the first step then. Log of 19 to the power x minus 5 equals log of 3 to the power x plus 2. Okay, so now I'm going to multiply. X log 19 minus 5 log 19. My hand actually hurts from so much writing. There's so much writing for these questions, hey? You like it? Okay, we're going to move the x's over and blah, blah, blah. So x log 19 minus x log 3 equals 5 log 19 plus 2 log 3. I'm going to just say what x equals because I know I'm going to factor it out. You see what I'm saying? I'm trying to save my handwriting. My poor hand. Okay. And we got 9.1663. Very good. Very good. Okay, let's do the next one. This is just a potpourri now. Potpourri means it has no rhyme or reason why this got included on here. Let's see if you remember how to do it. See, that's the hardest thing about this unit is when I teach it in small little chunks, it's easy to remember. It's when it's all mixed up at the end, you have to know which method you use for what, right? Yes, I heard somebody say this is a smiley face. It is. It's a smiley face. Yeah. Okay, try it. Okay, this is a non-calculator question. We're going to take 2 and put it to the power -2, and that equals your happy face, which is log of x base 81, yes? 2 to the power -2 is 1/4 equals log of x base 81. So that means 81 to the power 1/4 equals x, so x is 3. Okay, the next one is just a calculator question. It's the same as the, I don't know why I put it up there. See if you're paying attention, I guess, maybe, I don't know.
2.2920.
X equals 2.2920? Okay. And it's approximately. Huh? It doesn't make sense to go 5 to the power x equals 40 because you'd be going back. This is just a change of base, or use your fancy calculator function, punch it in and get a number, right? Does everybody know how to punch it in? Log 40 divided by log 5. X equals log of 40 divided by log of 5.